In the present video, we're going to continue our series of algebra using Maxima, and we're going to see how to solve systems of first order equations, system of linear equations, simple ones with two variables. But just to give you an idea how to get started with the things, we're going to start with our worksheet using Maxima. For example, we have two equations, 2x plus 3y is equal to 13, 4x minus 5y is equal to 5. What are x and y? So we're going to present the equations right here. 2x plus 3y equals 14, 4x minus y equals 5. If we use the solve in both equations, we can find expressions for y, and then we can equate them. Now I'm kind of like using high technology here to solve, and it's not that complicated to actually solve for that, but I just did it to save some time. So if we equate the right hand side of those two results, the result is this equation. And now, the steps to solve this should be very simple. And I find that x is equal to 29/14. If I now replace this value in each one of these, or only in one of them actually, I did it right here in the first case and here in the second case, you should be getting the same result. And that's one way to solve. So again, what I'm skipping here are the steps of solving for a single variable, which we already know how to do by using solve anyway. So this process is to isolate one of the variables, equate the two results, solve for the remaining variable, and then go back to the two expressions here to find the other variable. That's one method of solving, which is simply equating one variable from two equations. We can also do substituting one variable into an equation. For example, if I start with these two values, solve for x from the first one, and substitute that result into equation 2. So I take this value with the minus sign, put it in here, expand. Actually, the substitution Maxima took care of the denominator. And then we solve that equation for y, and once we have y, substitute that result into this expression to find the remaining unknown. Okay, so that's the case then where we isolate one variable from one of the equations, replace it into the other one, so that what results is an equation in the other variable, and then when that variable is solved, we go back to this expression to obtain the first value. Reduction by multiplying equation. This one. You gotta look for by inspection and say, okay, if I multiply this one by 4 and this one by equation 1 by 4 and equation 2 by minus 5, let's see what we get. So these are the two equations. We get a 20 and a minus 20x in there. So we took this 4 times 5 and 6 times 3. Multiplying equations. All right, so we have the problem here is that Maxima changes the order of the equations, but I have 5 here and 40 here. If I multiply this by 4, I get a 20 here. If I multiply this by 5, I get a 20 here. But I'm going to multiply the first one by 4 and the second one by minus 5. When I do that, then my x get 20 and minus 20. So if I add term by term by simply adding equation 3 plus equation 4, the x disappears and I'm left with y. And I notice that y is multiplied by 39, so if I divide by 39, I get my result of y equals 5. Then what I have to do is substitute this y into one of the two equations, 1 or 2. I did it in 1 here, and solve for x. And this is the solution of a single equation, which is something we know how to do. And so we end up with our values of x equal -2 and y equal 5. Now, if we want to use Maxima, what we can do is put the two linear equations into a list and put the variables to be solved for in another list. And so we're solving those two equations. For x and y, we find x equal 1/2, y equal 1/2. Just to check on that, I'm going to say substitute, and I'm going to borrow that list inside and do Control-C, Control-V, comma, and then I'm going to copy my list of equations, Control-C, Control-V, do Shift-Enter, and I get 32 equals 32, minus 5 equals -5, so the equations are satisfied. Here I'm going to have another problem. I can just do these and obtain my results. With literal coefficients, using solve is an incredible simple way to solve equations. So we get x equal a, y equal b. Here's another exercise. System of linear equations. We get x equal b plus a, y equal b. A third exercise with literal coefficients. Solving, that's what we get. Now, at this level of algebra, from the textbook that I'm looking at, they do system of two equations because it was all done by hand, and we saw three approaches: equating the same variable, substituting the variable, eliminating one of the variables. Now, I'm going to go further here and give you a system of three equations with three unknowns. Now, this is more difficult because you have to be eliminating one variable in a pair of equations and another pair of equations, and then eliminate the other variable in the two resulting equations. And so by hand, it gets complicated. But if you just solve in Maxima, your results come out right away.